All right, guys, so I'm going to basically work through all the questions on the review really quick. I'm going to move pretty fast. If you need to rewind and listen to it again, you can, or if you just want to fast forward to get to a question that you don't understand, then feel free to do that. I'm probably going to do this video in 2 different parts because the review's so long. So yeah, here we go. We're going to get started. So the first one is asking us to rotate the rectangle about the y-axis. It is important that you pay attention to which axis you're rotating around because, of course, it would change the radius and the height. So remember, it's going to kind of look like this, right, when we rotate it around, right, something to that effect. So that means that the radius of the cylinder is going to be 3, and the height of the radius is going to be 4. Right, and so that's really all you need, right, just to understand that it would make a cylinder, and then of course you can find its volume, right, with r squared h, right, so pi 3 squared 4, and that of course is going to get us our answer of 36 pi, and I'm going to put units cubed because it's a volume problem. That's it. All right, number 2. Paint roller A has a length of 11 inches. Okay, so if you're not familiar, which I'm sure most of you probably are, but a paint roller, right, is a cylinder. Right, so I know that's kind of crooked, but that's okay, we'll live. Right, so here's the little paint roller, right, it's a cylinder, and it has a length of 11 inches and a diameter of 2, which of course means the radius, which is what I really care about, is 1. Right, so the radius is 1. And then there's paint, this is A. There we go. And then we have paint roller B that has a length of 7 inches. Oh, it's got a bigger diameter, so I'll make it bigger. Right, so it's 7 inches. I'm just going to curve this end, right? And it has a diameter of 3, so this would be a radius of 1.5. Again, you don't have to draw pictures, right? That's just, oopsies. Sorry. That doesn't really look like a 1. It looks like a 2, so I'm just going to put a little 1 right there. There we go. It says, which roller will spread more paint on a wall in 1 revolution? Well, obviously, if I take these cylinders and I coat them with paint and I put it on a wall and roll it, right, then that means we're only referring to the lateral surface area. Right, and so we essentially want to calculate the lateral surface area of both because clearly the round bases are not touching the walls, right? Only the lateral curved part. So we want to calculate the lateral surface area of each one. So that would just be 2 pi RH. So the lateral of the roller A would be 2 pi, a radius of 1 with a height of 11. And that's going to give us 22 pi square inches. So every revolution of the roller, that's how much wall space it's going to cover. And then we have the lateral area of roller B, again, 2 pi RH. So 2 pi, 1.5, and 7. There we go. And that's going to give us 21 pi square inches. So clearly, A wins, right? Because he's going to cover 1 more square inch, right? It's not too much, but he's greater, so he's going to cover more wall space, right? If you want to, you could put like a greater than sign, right? That's kind of our justification, right? That his lateral surface area is greater than the other one. Okay, number 3 is kind of confusing at first because you're talking about a cold capsule, right? Like a pill that you would swallow. And it tells you that it's 11 millimeters long and 3 millimeters in diameter. They want you to find the volume of the medicine that it can contain. And then it tells you that this is a cylinder with 2 half spheres. So I'm just going to kind of draw that in to kind of make more sense of the picture. Right, so I'm going to kind of put little ovals right here. Right, so you can very much see, right, that this is your cylinder, right, in the middle. And then we have those 2 half spheres on each end. Okay, so clearly, if we're finding the volume of this whole thing, which is basically a composite solid, right, we're going to be doing cylinder plus sphere because 2 half spheres, of course, make 1 full sphere, right? So we're going to be doing pi r squared h plus 4/3 pi r cubed. Okay, so when I start filling that in, we're going to notice we're going to run into a problem here pretty quick, right? So obviously the radius of everything is 1.5, right? Now the issue is the height of the cylinder, right? Because it's not 11, because 11 is the whole thing. So you just need to put just a smidge of thought into this, right? Because what's happening, sorry, let me choose a color. I don't want yellow. We know that the diameter is 3, therefore the radius is 1.5. Well, the radius of a sphere goes in infinite directions. So I know this is 1.5, I know this is 1.5, but I also know this is 1.5. Right, so every radius I could possibly draw in my sphere is 1.5. And the same thing, of course, is happening on this side. I can draw this radius, and I know he's also 1.5 because I can draw it in any direction. So that means we know that it's 1.5 from here to here, and it's also 1.5 from here to here. So clearly that's 3 millimeters taken up by the 2 radii of the sphere. Therefore, the middle has to be 8, right, to add up to that full total of 11, right? And so that's kind of our thought process to figure out that that height of the cylinder is 8, and that's what we're going to plug in there in our formula, okay? And then, of course, the sphere is 4/3 pi, and then 1.5 cubed. And then it's just a matter of simplifying all that. And I would highly suggest using your calculator and simplifying one term at a time so that you don't make a silly mistake. So 1.5 squared times 8, this gives me 18 pi. And then when I calculate 4/3 times 1.5 cubed, I get 4.5 pi. So when I add those together, I get 22.5 pi millimeters cubed. And of course, we'll leave all our answers exact unless it asks us to round. So that's going to be our final answer. All right, number 4, a rocket has dimensions shown. If 60% of the interior space, so we're clearly talking about volume, has to be used for fuel, then what is the volume of the rocket space that can hold other equipment? Okay, well, if 60% has to be used for fuel, then obviously we're looking for 40% of the volume, right? Because there's only 40% left in the rocket. So we're going to calculate the volume of this lovely design, right? Which is clearly a cone sitting on top of a cylinder. And then we're going to take 40% of whatever that volume is. Okay, so basically I'm going to kind of write this in one long formula like I always do. So the volume we are looking for is 40% of, which is essentially 0.40 or just 0.4. So 40% of pi r squared h, which is the volume of the cylinder, plus 1/3 pi r squared h, which is the volume of the cone. So this is the total rocket, and then we just want 40% of that. All right, and they basically give you almost everything you need. We'll have to do a little bit of work here in just one sec. So here we go. I'm just going to plug in what I do know so I can figure out what I need. So for the cylinder, right, pi, it looks like it's pointing to the diameter being 16, right? So clearly I'm just going to go ahead and mark this, right, that this is 8 from here to here, right? So the radius is 8. So pi 8 squared, and the height of the cylinder is 50, plus 1/3 pi. Obviously the radius of the cone is also 8. But now we need the height of the cone. Okay, so I'm going to go over here, right? I'm just going to kind of dash this little oval here. Right, we've done this lots of times. Right, we already know the radius is 8, but we need the height. And, oh, I overshot that just a scotch. Well, we'll pretend that's nice and pretty. Right, and so this would be the height of our cone. So clearly that's creating a right triangle That is a Pythagorean triple, if you know your triples. If not, do a quick little Pythagorean theorem, and you should get 15. So an 8, 15 Pythagorean triple. So that means the height of our cone is 15. So we're going to throw that in there, and voila. There's all of our beautiful numbers. Now we just get to throw all of that in our calculator. Again, I like to kind of take that in baby steps and do one term at a time so I don't mess things up. So here we go. I'm going to do 8 squared times 50. So 8 squared times 50. I'm getting 3,200 pi for that term. And then 1/3 of 8 squared times 15 gives me 320 pi. All right, I'm going to go this way because I'm running out of space here. So now that's going to be 40% of, well, that's clearly going to be 3520 pi. And so I'm going to go ahead and take that 40% of 3520. So I'm going to multiply that by 0.4, and that gives me 1,408 pi. And it doesn't really give me units. So again, I'm going to put u cubed. Okay, and that is our final. That's how much space is left over for anything other than fuel. Okay. All right, next question. A tunnel is built into a mountain. It's 800 feet long. Okay, so like this is like where, you know, this is like where your car would go in, right? So you're going through the tunnel, right? And so the tunnel is 800 feet long. So that would be, I can label this edge right here. Its cross section is a square topped by a semicircle. So basically what they're telling you is if you were to slice through, right, any part of this anywhere, you're going to get a square with a semicircle on top, which tells me I can go ahead and I'm just going to go ahead and make that right here. If you want, you can go ahead and do that. I'm going to kind of draw this in so it helps us visually, right? And so I'm going to cut across and kind of connect that here, right? So that's kind of, I don't know if that helped or made that worse. So that's kind of what we're looking at, right? This is like the plane, right? That separates the rectangular prism on the bottom and then the half cylinder on the top, right? So that's what I want to make sure you're seeing, right? That this is a rectangular prism, right? And then the top is half of a cylinder. Okay, so that's what they're trying to get you to see. There we go. All right, so it says that the tunnel is 24 feet wide at its base. So that's 24. And it tells you it was a square with a semicircle cross section. So that's 24 by 24, which of course means the radius of our cylinder is 12. Just kind of labeling everything I can. How many cubic feet of rock was removed from the mountain to create this tunnel? So essentially we're just finding the volume of this, right? So we are doing a volume question of a rectangular prism plus a half a cylinder. Okay, so we just need to get our formulas going. So here we go. The volume formula for a prism is area of the base times height. And then the volume formula for a cylinder is pi r squared h, but I only want half of it. So 1/2 pi r squared h. All right, now as far as the capital B goes, remember with rectangular prisms, you can have any side you want be the base, okay? So if it's okay with y'all, I'm going to choose the front. I'm going to choose the front and the back actually to be my bases. That way the height of my prism is the same as the height of my cylinder, and I don't get those two things confused, okay? You can have the top and the bottom be the bases, and the 24 is the height of your prism, right? It doesn't matter. You'll get the same answer either way. So here we go. So the area of, so the capital B in this case is going to be 24 squared. right? And 24 squared is going to give us 576. So that's the capital B. That's my little side equation over there. So 576. And then the height of my prism is 800. So some pretty big numbers, right? And then my cylinder, 1/2 pi, the radius is 12. And the height of my cylinder from circle base to circle base is also 800. All right, and there you go. Then your job is just to clean up that mess. And again, obviously my answer is going to be a binomial because prisms and cylinders don't play nicely with each other. All right, so I'm going to get 460,800 plus, and let's see, 12 squared times 800, and then times, and I'm going to cut that in half. So we're going to get plus 57,600 pi cubic feet of rock were removed to create this tunnel. Voila, prism plus cylinder. All right, moving on. Number 6, a cement water supply pipe is 5 miles long. It has an outer diameter of 7 feet and an inner diameter of 6 feet. Okay, what is the volume of cement needed to make this pipe? So clearly we are finding the volume, right, of just the outer cylinder, right? So we already know that this is going to be cylinder minus cylinder, like we've talked about so many times. Now, the kicker on this one is my diameters are all given in feet, but the length of the pipe is given in miles, and that's clearly not going to help me out. So we need to make sure we convert the miles into feet. If you don't know how many miles are how many feet are in a mile, that's okay. I'm going to write that down. So 1 mile equals 5,280 feet. And I totally forgot the zero. Hold on, 5,280, there you go, feet. And so we're going to take that 5,280 feet because we want 5 miles. So I'm going to multiply that by 5. So I'm going to go over to my picture. I'm going to cross that out. So this pipe is 26,400 feet long. I mean, clearly it's not drawn to scale, but you get the gist of the picture. All right, and so now I can actually answer the question. It says, what is the volume of the cement needed to make this pipe? Well, that's just going to be cylinder minus cylinder, right? The big cylinder's volume minus the inner cylinder's volume, and that will give us what is left, right? So volume equals pi r squared h minus pi r squared h. And I'm going to go ahead and write like this is the big cylinder, and this is the small, right? So it's not like they're canceling each other out, right? The radii are obviously going to be totally different for each of those equations. All right, so here we go. I'm just going to kind of go off to the right over here. So pi, the radius of the big pipe is 3.5 squared. And of course, that big height of 26,400 minus the small pipe's radius, which is 3, so pi 3 squared. I'm going to scooch this over. Times the same height of 26,400. And then I'm essentially just throwing that all in my calculator. I'm going to get some really big numbers. So 3.5 squared times 26,400. So that's going to give me 323,400 pi. And then we're subtracting 3 squared times 26,400, which gives me 237,600 pi. And then we're going to take that 32, we're going to subtract those two pi terms. I'm just going to go copy and paste those and do that subtraction. And I am getting 85,800 pi cubic feet of cement are necessary to make that pipe. That's a lot of cement, right? Especially because you still have that pi multiplier in there. All right, it says, what is the volume of water contained in the pipe if it is full? Okay, well, if it's a pipe for water, well then clearly the water is only going to go inside the inner cylinder of the pipe, right? So we just want the volume of the inner cylinder, and we already have that answer, right? We already did that right here, right? And so I don't have to do the work again, right? I know the answer is 237,600 pi cubic feet of water. If you want to do all the math again, you can, but again, you did that right here when you found the volume of the inner cylinder. So no need to double back and do it all again. All right, number 7. I like this question a lot. It says, a tennis ball container barely holds 3 new tennis balls. They're stacked end to end. The balls are loaded in, then the remaining air is sucked out of the container, and the container is sealed. The average tennis ball has a volume of 288 pi cubic centimeters. All right, so then it says, what is the area of a label that covers the entire outside of the container? All right, so clearly if we were to wrap this entire container, right, the wraparound part in a label, then that would just be lateral surface area. Right, so that's all we're doing here. It's just a lateral surface area problem of a cylinder, which is just 2 pi RH. Now, what I really love about this question is they didn't tell me the radius or the height, right? But they did, the only number they gave me was the volume of a tennis ball. Well, a tennis ball is a sphere, right? Well, spheres are awesome because they only have one variable, right? So I'm going to use the sphere's volume to calculate the radius, and then I'm going to use the radius to find the height, and then I'll be able to find the lateral area for the label on the can, right? So this is a very multi-step problem, okay? So let's start by solving for the radius. So we're going to do volume equals the sphere formula, which is 4/3 pi r cubed. I'm going to go ahead and erase that V because I'm kind of limited on space here. I'm just going to replace that with the 288 pi. 288 pi. So this is the equation that we're going to be solving. Again, we've talked about this lots of times, right? If you want to, since there's a pi on each side, you can just divide that out and it's gone. So really all I'm doing now is I'm dividing both sides by 4/3. Please use the fraction mode on your calculator. So many of y'all missed this quiz question because you're just not typing it in your calculator correctly, right? So make sure you either use the fraction mode and type it in top to bottom exactly like it looks on your paper, or make sure you put parentheses around the 4/3, right? So your calculator knows you're dividing by that entire quantity, okay? Either way, let's see, we should get 216. Right, so I'm going to get 216, back to orange, 216 equals r cubed. And then, of course, to solve for r, we just need to cube root that. Right, so the cube root of 216 is 6. I don't know why I just typed that in, I knew that. So the radius is 6. Okay. Well, that's great because now if I go back to my lateral area formula, which is the whole goal, I can type in a 6 for the radius, which is why it's so amazing to write your formulas down so you know exactly what you need and when you need it, right? And then you're like, height, what is the height of the cylinder? They didn't give me that either. Well, right, if you think outside the box a little bit, right? We are assuming when we answer this question that the tennis balls are going all the way from the top of the can, right? The top of the tennis ball goes all the way from the top of the can to the bottom of the can, right? And so, of course, each one of these tennis balls has a radius of 6. So 6, 6, 6, 6, 6, 6. So they all have a diameter of 12. There's 3 of them, which means our height of the can is going to be roughly 36 centimeters. All right, so we use the radius of the tennis balls to calculate the height of the can. And voila, now we know that that's 36. And then we can just do our math, right? And do our 2 times 6 times 36, which is going to give us 432 pi square centimeters would be the size of the label that we need for the can. Ta-da! All right, then on to question or part B. What is the volume of air that is sucked out of the container before it's sealed? So yet another composite solids question, right? Because we want to know the volume of all of the space around the tennis balls, right? So this is definitely a composite, right? Where we're going to do the volume of the cylinder minus the 3 tennis balls. So that is going to be pi r squared h minus 3. And I already know the volume of each tennis ball. They gave us that in the prompt already. So each one is 288 pi, and there's 3 of those, right? So we can just multiply those spheres by 3. So I just really need to find the volume of the cylinder. So pi, we already know the radius of the cylinder is 6. Because it's the radius of the ball. We're assuming it's touching the sides. And the height of the cylinder is still that same old 36. And then minus, I'm going to go ahead and multiply that. So 3 times 288 gives me 864 pi, being the volume of all 3 tennis balls. And then let's see, 6 squared times 36 is 1296 pi. So that's the volume of the cylinder minus the volume of the 3 tennis balls, right? So we're going to subtract the 864 pi from the 1296 pi, which gives us, what a coinky dink, 432 pi, right? The same number, but not the same answer because these are cubic centimeters, right? And not square centimeters. So I know it's the same number, but it's not the same meaning with the different label there. Again, it's because the radius is 6. It kind of did that, remember, in our notes also. Okay. I think I'm just going to finish these last 2, 8 and 9, and then I'll stop this video, and then I will make another one when we get to number 10. All right, so here we go. Below is a diagram of my swimming pool. How many cubic feet of water will the pool hold? Okay, now this, for some reason, this problem tends to cause issues because some people, when they look at this 3D drawing, their brain interprets it a little bit differently than what it's supposed to be. So I just want to make sure we all understand, get a nice pretty blue color here, that these little waves up here, this is the water in the pool, right? Which I know is probably obvious, but okay, so this is the pool water, which is of course flat. Right, so the top of this is the flat horizontal water, but then it is a swimming pool, right? So we have, blue. There is a shallow end, and then if I go straight across, right? So we have a rectangular prism on top, but then of course there's the deep end of the pool. So this is actually going deeper into the earth, right, where you've dug out the deep end of the pool. Does that make sense? So this is basically a right triangular prism on the bottom and then a rectangular prism on the top. Or if I were you, I would also think about this as you could also think about it as a trapezoidal prism because the entire front of that is a trapezoid, and that would actually save you some time. So I'm actually going to solve it that way, right? So the front of this is a trapezoid, right? And then of course the back is the other trapezoid base back here. If you'd rather split it up to a triangular prism and a rectangular prism and then add them together and do it as a composite, that's totally fine. You'll get the exact same answer. Okay, so here we go. We're going to tackle this as a trapezoidal prism. Okay, so because it's a prism, we know the volume formula is area of the base times height. So clearly my main issue is going to be the volume of the trapezoid. I'm sorry, the capital B being the area of the trapezoid. So I'm actually going to do that math over here off to the right. So of course trapezoids are 1/2 height times base 1 plus base 2. And we have all this information, right? Now the height of the trapezoid is the distance between the two parallel bases, right? The 5 feet and this 15, that does say 15, yeah, sorry. The 5 feet and the 15 feet, those are the parallel bases. So this guy right here is the height of our trapezoid, which is the 24. Right, so just be really careful that you're picking the right numbers. The height of the trapezoid is 24, and then the two bases are the 5 and the 15. All right, so when I do that, right, we're going to be getting, obviously half of 24 is 12, right? And then we're multiplying the 12 times the 20, which is going to give us 240 square feet. All right, so back to my formula. 240 is the area, is the capital B, the area of our trapezoid. And then we're going to multiply that times the height of the prism itself, which would be the distance from one trapezoid to the other trapezoid base, which is going to be this 10 right here. So the height is 10. So voila, the volume of our pool is 2,400 cubic feet of water could fit in the pool. And like I said, you'd get the same thing if you wanted to split that up with a rectangular prism sitting on top of a right triangular prism. You're going to get the exact same answer. Okay. All right. Number 9. This is going to be a SPOV chart question, right? Because clearly, right away when I start reading that, it says solid A is similar to solid B, right? So I clearly know this is a SPOV chart question. With the given scale factor of A to B, the surface area and volumes are given. Find the surface area and volume of B. Okay, I'm going to have to write pretty small because this is 3 different problems in this little tiny space. So here we go. So for A, I'm going to kind of put my little SPOV chart over here, nice and tiny, kind of tuck it away. So the scale factor of A to B, and I'm going to keep that very straight. I'm going to kind of write that over here. Everything that we do is A to B. So the scale factor is 1 to 4, which means my perimeter ratio is 1 to 4, which means my area ratio is 1 to 16, which means my volume ratio is 1 to 64, right? Because we're cubing the 4. Okay, and now that I have that, I should be able to solve for the missing values. And it says the surface area and volume of A is given, right? So all of this information right here is about solid A. And again, I don't know what shape it is. It could be a cylinder, a cone, a prism, I don't know, and it doesn't really matter, right? So when I set up my proportion, and again, no, you don't have to set up a proportion, but I'm totally gonna. So for my first proportion, I'm gonna do surface area, which means I need to be using the 1/16 formula. Orange. So I know that's gonna be 1/16, and then I'm gonna use that A is 62, so that's going to go on the top, and then I'm looking for B. So clearly we're just cross multiplying and just multiplying 62 by 16, which makes perfect sense because the volume or the area is 16 times bigger. So 62 times 16 gives us 992 square centimeters for solid B. All right, but then for solid A, right, we are going to be finding the volume, which means I now need to be using the volume formula in my proportion. So I'm trying to color code this. So I know that the 1/64 has to be in there. And if the volume of A is 30, that goes in my numerator, which means the volume is 64 times bigger than 30. So clearly when I cross multiply, I'm just going to be multiplying 64 times 30, which gives me 1,920 cubic centimeters. Okay. And the rest of these examples are basically all the exact same, right? So I'm just going to run through these really quick. You can feel free to fast forward if you want to, right? My SPOV charts, right? Now my ratio is 1 to 3. So 1 to 3, 1 to 9, 1 to 27. So again, I'm just going to go ahead and set up my two proportions, right? One for volume, one for surface area. All right, I'm going to kind of do the same color coding. I'm going to try to keep it straight here. So again, surface area means I need to be using the 1/9 ratio because anything that has to do with area is going to be 1 to 9. And they're telling me that the surface area, again, this is all A information. So I'm going to put that in the numerator. So 112 pi over x. So I'm just going to multiply 112 times 9, which gives me 1008 square meters. Sorry about that. Again, it's just the same process over and over. SPOV chart, proportion, solve proportion. Okay, and then we need our volume. Well, if I'm solving for volume, I must have the volume ratio, which is 1 to 27. So if A is 160 pi cubic meters, then how many cubic meters is B? So clearly we are just going to multiply 160 by 27, which gives us 4320 pi cubic meters. Now, obviously, all of those proportions are quite simple because our numerators are 1, right? So we didn't have to do a whole lot there. The next one's going to take a little bit more work just because the ratio isn't 1 to something, it's 2 to 5, right? So that means when I zoom in, let's make that straight. There we go. So okay, sorry, it's going to bug me. Okay, so when we make our SPOV chart, so the side ratio or the scale factor is 2 to 5. So perimeter ratio 2 to 5. We square 2 to 5 to get 4/25, and then we cube 2/5 to get 8/125. And now that we have all that wonderful information, now just like we did before, we can set up one proportion for area, one proportion for volume. Again, if I want to do area, then I have to have the 4/25 because everything has to be about area. And then A has a surface area of 144 pi, and then we're solving for B. So again, we actually have a second step here, right? Because we've got a 4x equals some large number, 3600 pi. And obviously we're going to divide by 4, which is going to give us 900 pi square yards. Voila. And then if we want to find our missing volume, well, then we know in that proportion, we must use the 8/125. And given the volume of solid A is 288, what is X if everything has to reduce to 8/125? So again, we're just cross multiplying. Again, another really big number, 125 times 288. So 36,000 pi. And then we divide by 8, right? And we're going to get 4,500 pi cubic yards. Okay. All right, number 10 is a lot, right? Because it's got parts A through T. Sorry about that. So I'm going to do that in the second video because there's a lot going on all those shapes. But we've basically kind of covered all of the composite figure questions. And then I think there'll be a few more SPOV chart questions. But that takes care of a big chunk of the first part. I know it was only 9 questions, but there's a lot going on in those 9 questions. Okay.